Assalamualaikum. Myself Ahmed Rama, roll number 21, PV76, and I am going to give the presentation on the topic of adoptive filter. First of all, we will discuss its intro, which is that adoptive filters are a crucial component of signal processing. They dynamically adjust a parameter to optimize performance based on incoming data. The adaptive nature allows them to handle various challenges such as noise reduction, echo cancellation, and channel equalization, making them highly versatile. Adaptive filters can adjust them according to the device. These, these are such an adjustable filters that they are frequently used. These are the four fundamental components which are filter structure, adaptive algorithm, convergence criterion, and application domain. First of all, filter structure. Adaptive filters often employ a finite impulse response structure which allow for a flexible and controllable frequency responses. And then the adaptation algorithm. These algorithms update the filter coefficients based on the error signal, which is difference between the desired output and the actual output. By using the FIR filter structure, the data analyzation and noise cancellation become easy for the adaptive filters and for the adaptation algorithm, filter coefficient error signal, which is difference between the desired output and actual output. By using the error detection method, it is easy for adaptive filters to detect error and cancel noise. Now the convergence criteria. This goal is for filter coefficient to convert the optimal values that minimize the error signal, uh, enabling the filter to effectively adopt to the changes criteria of the input signal. Like when we give the signal to the adaptive filter, it will be set according to the adaptive filter will be set according to the signal we will give and analyze it according to that. Application domain. Adaptive filter find widespread use in various fields such as communication, biomedical engineering, acoustics, and control systems. It uses two algorithms. First is lead mean square algorithm, and second one we will discuss in next slide. So first of all, lead mean square algorithm. There are three steps: calculate the error signal, update filter coefficient, repeat for new data. So the difference between the desired output and actual output is computed in the first step, and then the second step, the filter coefficient are adjusted proportionally to the error signal with a step size controlling the rate of adoption. Like where we have a signal, so its filter coefficient which is according to the error signal. Like the signal we will get after the error detection is for the coefficient are set according to that to control the step size of adoption. And the last step repeat for new data. The process is repeated for each new data sample, allowing the filter to continuously adapt to the changing input. Like for every data set, it is different to filter, adjust, or adopt according to that. Now the next step, which is recursive least-square algorithm. Um, so it's also has three steps and its advantage and disadvantage. The LRS algorithm is more computationally intensive approach compared to the LMS algorithm, but it offers faster convergence and improved performance in certain scenarios. Like its approach is also very difficult as compared to LMS, but it is easy to convert data and to detect error in this method. Body exhibit is the advantage of orderless algorithm. It exhibits faster convergence, especially in non-stationary environments, and can track time-varying signal more effectively. Like it can convert signal faster, detect error fastly, and can uh, get the signal accurate. Disadvantage is that the increased computational complexity of RNS algorithm can make it less suitable for real-time application with limited processing power. Like as it is very complex to apply, so maybe in the future it will be difficult to use this method. Now Now the applications of adaptive filter, it is used for as it is effective to use because it can adopt according to the signal as have we have the signal, so it can adopt according to that. So its application, the Wi-Fi the main problem is that it is complex to apply. So its application are noise rejection, echo cancellation, channel equalization, medical signal processing. While this adaptive filters can effectively remove unwanted from signals such as background noise in audio recording or interference in communication. Echo cancellation, they are widely used in telephony to eliminate echoes caused by long transmission and improve the clarity of conversation like we have in our homes, telephones. Adoptive filters are used in them. It is a widely used filter. Channel equalizer. Adoptive filter help compensate for distortion introduced by communication channel, enabling reliable data transmission over unreliable links. So by equalizing the channel, it will be easy for the noise to be to communicate, and it will be easy to detect signal and correct it. Medical signal processing, it is used in ECGs and WEGs for diagnosing and monitoring. Now its advantages and limitations. Disadvantages are that it can adopt according to any condition, that if we give it any condition, it can adopt according to that. It is effectively reduce noise and it is used in wide application because as it can be adopted according to any signal, so it is widely used application. But at the same time, it has some limitations which are that it is complex to apply. Convergence speed can vary according to the signal. That if we have a large signal, then its convergence can vary. So sensitive to initial conditions. Yani, as we give the two conditions before, so it can be sensitive to them. Now the convergence has stability consideration. As I discussed that it can its convergence can vary. So it has we have 3 points for convergence stability consideration. Is step size, initial condition, and data status. The step size control the rate of adoption. A larger step can lead to faster conversion but can also cause instability. Like as the step size increases, so convergence can be faster, but it can cause a system instability. So due to that, the error correction, detection, and noise stability can be initial condition. The initial values of filter coefficient can influence the convergence path and stability of the algorithm. That the conditions we have before can affect the convergence path and stability of algorithm. Now the statistical properties of the input signal can affect the convergence behavior and stability of the adaptive filter. Uh, Now the future trends in adoptive filters, it can be used in AI, cloud computing, IoT, and 5G communication. Integrating AI into adaptive filtering has the potential to enhance performance and create intelligent filter that can learn and adopt autonomously. Cloud computing, cloud-based adaptive filter enable distributed processing and access to massive data set, enabling the development of more powerful and efficient filters. IoT adaptive filters can are becoming increasingly tools in IoT application where they can be handle noise and have data from industry devices. 5G communication adaptive filter play a critical role in 5G network, enabling high-speed data transmission and reliable connectivity in complex environments. That's all. Okay, Allah.